Question 15 asks us to write an equation for a sine function with a maximum value of 8, a minimum value of 4, a period of 2 pi over 9, and a phase shift of pi over 2. So we can write the general form of a sine function as y equals a sine b times x minus h plus k, where a influences the amplitude, b influences the period, h influences the phase shift, and k is the vertical displacement. Okay, so we can figure out what the amplitude is of our function that we're interested in, because the amplitude is equal to the max value of our function minus the minimum value over 2, because the amplitude is a distance between the center line of our sine function to either the max or the min. So plugging in our max and min values, our max is 8, our minimum is 4. So 8 minus 4 is 4. 4 divided by 2 is 2. So the normal amplitude of the sine function y equals sine of x is 1. So we've basically multiplied that normal amplitude by a factor of 2, and therefore a is equal to 2. Okay, so moving on to the period, we know that the normal period of the sine function y equals sine of x is 2 pi, and we can figure out this period changes due to b, and so the way it changes is that the normal period 2 pi is multiplied by 1 over the absolute value of b to equal the new period. So we know that the period of our function is 2 pi over 9. So 2 pi over the absolute value of b has to equal 2 pi over 9. And so the absolute value of b must equal 9. And we can just say that b is equal to 9 because we haven't been told any reflections in the x or y axis. Sorry, I misspoke. So if a is negative, we'll get a reflection in the x-axis, but we haven't been told there's been one, so we'll keep it as positive. If b is negative, it doesn't matter because it's the absolute value that we're interested in, and that's what changes just the period of our function. So moving on, let's look at the vertical displacement of our function. So a normal sine function of y equals sine of x has its center line at 0, but ours has been shifted upwards because our minimum is now at 4. So if we think about a normal sine function, after we've done this change to the amplitude, its minimum is going to be at -2 and a max at +2. Since our minimum is at 4, what we've done is we have done a vertical displacement by 6 units. So we can say our vertical displacement is 6, and therefore the variable k must equal 6 because we've gone up, so it's positive. The last thing is our phase shift, which is h. We've been told our phase shift is pi over 2, and that's a movement left or right. So that one's easy, and we can just say h is pi over 2. It's positive, so we've moved to the right. So now we know all our variables, and we can plug them into this general form. And what we get is y equals 2 times sine of 9 times x minus pi over 2. We said pi over 2 is positive, but this negative sign is just inherent in our general form, and a plus 6 on the outside. So this is an equation of a sine function that matches this criteria in the question, and we've answered question 15.